This is the EdExcel A-Level Maths Paper 1 from the June 2022 series. Question number 1. The point P with coordinates -2, -5 lies on the curve with equation y equals f of x, where x is a real number, and we have to find the point to which P is mapped when the curve with equation y equals f of x is transformed to the curve with the following equations. Now, before we do anything else, let's just sketch some graph y equals f of x with the point P on it. Something looking like this. We've got the point P with coordinates -2, -5. And so, for part A, if we have y equals f of x, and then we transform this to y equals f of x plus 2, this would be a translation by vector 0, 2. So we've got our graph, and then what we need to do is move this graph 2 units up, something looking like that. And then what we have done is add 2 to the y coordinate, so this coordinate would then become -3, and that's because we have -5 plus 2, which is -3. Let's call this P dash, say. And so the mapped coordinate is -2, -3. Next, for part B, we have y equals the mod of f of x. Well, for part B, if we have y equals the mod of f of x, what we have to do here is reflect the negative part of the graph in the x-axis. So here we've got our original graph, and what we need to do is reflect this negative part in the x-axis. And so P will be moved to this point. The -5 would become +5. We take the absolute value of the y coordinate, so we have -2, 5 for the coordinates of P dash. So this is the graph of y equals the mod of f of x. And then for part C, we have y equals 3 times f of x minus 2 plus 2. Well, what we have then for part C, we are going from y equals f of x to the graph of y equals 3 times f of x minus 2 plus 2. Now here the order definitely does matter. If we have y equals f of x, what we can go to is the graph of y equals f of x minus 2, and then after this we have to multiply by 3 first and then add the 2. If I add the 2 first to give y equals f of x minus 2 plus 2, and then if I multiply this by 3, I have to multiply the entire thing by 3, and we won't maintain equivalence in that case, which is why what we have to do is multiply by the 3 first. So we have y equals 3 times by f of x minus 2, and then we add the 2. So what we have first is the translation by vector 2, 0. Then we've got the stretch scale factor 3 in the y direction, and then we've got the translation by 0, 2. So here is our graph. First thing we will do is we will translate it by 2, 0. So we're moving it 2 to the right. And then when we do that, this coordinate here becomes 0. And then what we do is we stretch it scale factor 3 in the y direction. So I multiply this minus 5 by 3 to get minus 15. And then what we do is we translate this by moving it 2 units up. So if I move it 2 units up like so, then we add to minus 15 2, and so what we end up with is the coordinates being 0, minus 13. And so therefore, for part A, here is the graph of y equals f of x plus 2. Then for part B, we have the graph of y equals the mod of f of x. And then for part C, we've got the graph of y equals 3 times by f of x minus 2 plus 2, as we see here. Question number 2. We are given that f of x is equal to x minus 4 multiplied by x squared minus 3x plus k minus 42, where k is a constant, and we are given that x plus 2 is a factor of f of x, and with this we have to find the value of k. Well, first of all, if x plus 2 is a factor of f of x, that means that f of minus 2 is equal to 0. So if we work out what f of minus 2 is, we have minus 2 minus 4 multiplied by minus 2 squared minus 3 multiplied by minus 2 plus k minus 42. And this is equal to 0. And so what we have then is minus 6 multiplied by, well, here I've got 4 plus 6, which is 10, plus the k. This is equal to 42. If I take over this minus 42 to the right hand side, we have positive 42. And if we divide through by minus 6, that means 10 plus k is equal to 42 divided by minus 6, which is minus 7, in which case we see that k is equal to minus 17. And so therefore, f of x is equal to x minus 4 multiplied by x squared minus 3x minus 17 minus 42. Question number 3. A circle has equation x squared plus y squared minus 10x plus 16y equals 80, and with this we have to find the coordinates of the centre of the circle and the radius of the circle. Well, for part A, we begin with x squared plus y squared minus 10x plus 16y equals 80. If we complete the square of the x's and the y's, we have x minus 5 squared, subtract the square of 5, plus y plus 8 squared, subtract the square of 8, and this is equal to 80. So I've got x minus 5 squared plus y plus 8 squared, that's equal to 169. X minus 5 squared plus y plus 8 squared is equal to 13 squared. And in this case we can see the coordinates of the centre. We've got 5 minus 8, and the radius would equal 13. Now for part B of the question, given that P is the point on the circle that is furthest away from the origin, we have to find the exact length, or P. So for part B, we've got our circle with the centre at 5 minus 8. And the point that's furthest away from the origin will be over here somewhere. And here we've got the origin, and here we've got our radius of 13. And we need to find out the distance from the origin to the centre, and that would give us the length, or P. So to find out this length, we have, going down from here, a length of 8, and then going across we have a length of 5, and so through Pythagoras the square root of 8 squared plus 5 squared is root 89. So here we have root 89. And so the distance, OP, that's equal to root 89, which is the distance from the origin to the centre, plus the 13, which is the radius of the circle. So this is the exact distance, root 89 plus 13. Question number 4, for part A, we have to express the sum from x equals 2.1 to 6.3 of 2 over x delta x as the limit of delta x tends towards 0 as an integral. Well, if we've got this sum over here, this is equal to the integral from 2.1 to 6.3 of 2 over x dx. We've got the limit of a sum. And now for part B, we have to show that this sum is equal to the natural log of k. Well, what we know from part A is we are integrating 2 over x between 2.1 and 6.3 with respect to x. And if I integrate 2 over x, I get 2 times by the natural log of x. And I am evaluating this between 2.1 and 6.3. And substituting in my limits, I've got 2 times by the natural log of 6.3, subtract 2 times by the natural log of 2.1. And using the subtraction law of logs, that's the same as 2 times by the natural log of 6.3 over 2.1. So we've got 2 times by the natural log of 3, and using the power law, that's the same as the natural log of 3 squared. And it turns out we get the natural log of 9. K is equal to 9. Question number 5. The height h meters of a tree 2 years after being planted is modelled by the equation h squared equals at plus b, where t is in between 0 and 25 and a and b are constants, and given that the height of the tree was 2.60 meters exactly 2 years after being planted, and the height of the tree was 5.10 meters exactly 10 years after being planted. For part A, we have to find a complete equation for the model, giving the values of a and b to 3 significant figures. Well, what we can do is substitute in these conditions into our equation. So, when t is equal to 2, we have h, which is equal to 2.60. So I've got 2.60 squared equals a multiplied by 2 plus b. And if I work out 2.60 squared, I get 6.76. So I have 2a plus b equals 6.76. And when t equals 10, h is equal to 5.10. So I've got 5.10 squared equals a multiplied by 10 plus b. And so what we end up with is 10a plus b equals 26.01. We can find out what a and b by solving those simultaneously. And if we were to use our calculator, we've got our first equation, 2a plus b equals 6.76. Then we have 10a plus 1b equals 26.01. And so what you will find is the value of a is 2.41 and the value of b, that's equal to 1.95. And these are given to 3 significant figures. Now, whilst we're here, let's store these into A and B respectively, just in case we need to use them later on. And then for part B, given that the height of the tree was 7 meters exactly 20 years after being planted, we have to evaluate the model, giving reasons for your answer. Well, knowing the values of A and B, what we can do for part B is conclude that h squared is equal to 2.4 etc. t plus 1.9 etc. And if I square root, that would imply h is equal to 2.4 etc. t plus 1.9 etc. then square rooted. And so what we can do is find out the value of h when t equals 20. So when t equals 20, we have h equals 2.4 etc. times by 20 plus 1.9 etc. And then this is square rooted. So if I find out my value of h, we've got the square root of a multiplied by 20 plus b. And it turns out we get 7.076 etc. So because this 7.076 etc. is close to the real height of the tree, which is 7 meters, we can therefore conclude the model is good. Question number 6, we've got figure 1, which shows a sketch of a curve C with equation y equals f of x, where f of x is a cubic expression in x, and the curve passes through the origin. It's got a maximum at 2, 8, and it's got a minimum turning point at 6, 0. And for part A, we have to write down the set of values of x for which f of x is less than 0. Well, do you notice for every point between 2 and 6, the tangent to the curve is always negative. And so, where f of x is less than 0, that will be in between 2 and 6, because as we see, the gradient of the tangent is always negative between these two values. And so, for part A, we have 2, which is less than x, which is less than 6. Now, for part B of the question, the line with equation y equals k, where k is a constant, intersects C at only one point. We have to find the set of values of k, giving an answer in set notation. Well, if we've got y equals k, that will be a horizontal line. And do you notice that anywhere below the x-axis, we have one intersection point? And do you also notice everywhere above the y-coordinate of 8 is where we would also have one intersection point? And so we want everything above the line, that's where we would have one intersection point, and everywhere below here is where we would have one intersection point. So when we come to give our solution in set notation, we have k which is less than 0, and that would correspond to this region here, or we have k being greater than 8. So these are our set of values. Then, for part C, we have to find the equation of C. You may leave your answer in factorized form. Well, the general form of our equation, we would have y equals ax multiplied by x minus 6 squared. We have a repeated root at x equals 6. We've got a root at x equals 0, and the reason we multiply by a is because we need to stretch the graph based upon the information given here. And so we know that when x equals 2, y equals 8, so we have 8 equals a multiplied by 2 multiplied by 2 minus 6 squared. So we have 8 equals 32a, in which case we can conclude a is equal to 1/4. And so therefore y is equal to 1/4 x times by x minus 6 squared. This is the equation of C in factorized form. Question number 7 for the first part. Given that p and q are integers such that pq is even, we have to use algebra to prove by contradiction that at least one of p or q is even. Now we begin by supposing p and q are both odd. And if that's the case, then we have p equals 2n minus 1 and q equals 2m minus 1, where n and m belong to a set of integers. And now, if we find the product of pq, that means we have 2n minus 1 times 2m minus 1. And if I expand this out, pq is then equal to 4mn minus 2m minus 2n plus 1. And from these first three terms we can factorize out a 2, leaving us with pq equaling 2 times 2mn minus m minus n plus 1. And the result here is odd, and this contradicts the statement that pq is even. And so therefore at least one of p and q is even. Because if that's the case, then pq will be even. If both p and q are odd, we won't get the product being an even number. Now, given that x and y are integers such that x is less than 0 and x plus y all squared is less than 9x squared plus y squared, we have to show that y is greater than 4x. Well, for the next part, we have x which is less than 0, and this is given. What we also have is x plus y squared is less than 9x squared plus y squared. And if we expand the left, we have x squared plus 2xy plus y squared being less than 9x squared plus y squared. And recognizing that the y squared cancels from both sides, that means we have, when we simplify, 2xy being less than 8x squared, and if I divide through by 2, xy is less than 4x squared, and if I divide through by x, we have y being greater than 4x squared over x. Now, why does the inequality sign flip when I divide by x? Well, it's because x is less than 0, so the inequality sign is reversed. If x is less than 0, x squared is greater than 0. Multiplying that by 4, that's still greater than 0, but then if I divide by something which is less than 0, 4x squared over x will be negative, and that's why the inequality sign changes. And what we can conclude from that then is y is greater than 4x. Question number 8. A car stops at 2 sets of traffic lights. We've got figure 2, which shows a graph of the speed of the car v meters per second as it travels between the 2 sets of traffic lights. The car takes t seconds to travel between the 2 sets of traffic lights. The speed of the car is modelled by the equation v equals 10 minus 0.40 times the natural log of t plus 1, where t is in between 0 and t, and t is given in seconds, and it's the time after the car leaves the first set of traffic lights, and according to the model we have to find the value of t. Well, to find out this value of t, we notice that v is equal to 0. And so for part A of the question, when t equals t, v is equal to 0. And so we set equal to 0, 10 minus 0.40 multiplied by the natural log of t plus 1. And so either 10 minus 0.40 equals 0, or we've got the natural log of t plus 1 equals 0. So if I've got 10 minus 0.40 equaling 0, that means I've got 10 equaling 0.40, and if I antilog both sides of the equation, natural log of t plus 1 equals 0, that means I would have t plus 1 equals 1. And so from here then, we can see that t is 25, and if t plus 1 is equal to 1, that means t is equal to 0. And so therefore, the solution we require is t equals 25. When t equals 0, we're at the origin. For part B of the question, we have to show that the maximum speed of the car occurs when t equals 26 over 1 plus the natural log of t plus 1 minus 1. Well, the maximum speed of the car, that would imply to us we need to differentiate v. So we've got v equals 10 minus 0.40 times natural log of t plus 1. We need to differentiate this result. And so if we differentiate dv over dt, we've got 10 minus 0.40 multiplied by the derivative of the natural log of t plus 1, which is 1 over t plus 1. And then we've got the natural log of t plus 1 multiplied by the derivative of 10 minus 0.40, which is 0.4t. And so what we can conclude then is dv over dt is equal to 10 minus 0.40 divided by t plus 1 minus 0.4 times the natural log of t plus 1. Now, what we have to do then is set dv over dt equal to 0. And if we do that, we have 10 minus 0.40 over t plus 1 minus 0.4 times the natural log of t plus 1 equals 0. And if we rearrange, we have 10 minus 0.40 over t plus 1 equals 0.4 times the natural log of t plus 1. And if we multiply both sides by t plus 1, that means we've got 10 minus 0.40 equals 0.4 times by t plus 1 times the natural log of t plus 1. And if we divide both sides by 0.4, well, 10 divided by 0.4, that's 25. 0.40 divided by 0.4, that's just t. And on the right hand side we have t plus 1 times the natural log of t plus 1. Now, if we expand the brackets on the right hand side, well, the left hand side would remain the same, but on the right hand side we have t times the natural log of t plus 1 plus the natural log of t plus 1. And if we rearrange then, we can see that t times the natural log of t plus 1 plus t is equal to 25 minus the natural log of t plus 1. And on the left hand side, if we factorize, we have t multiplied by 1 plus the natural log of t plus 1. And on the right hand side, that remains the same as 25 minus the natural log of t plus 1. Now, if we pay attention to what we want to show, we have here t equals 26 over 1 plus the natural log of t plus 1 minus 1. And we want to somehow get to that result. Well, what we can do is actually rearrange. We can see from here that t equals, if I combine these terms, we have 26 minus 1 plus the natural log of t plus 1 over 1 plus the natural log of t plus 1. And do you notice from here that 26 minus 1 is the same as 25? So we are almost looking like we have shown our solution. So what we can do is rewrite the right hand side. The left hand side remains the same as t times 1 plus the natural log of t plus 1, but on the right hand side we can rewrite that as 26 minus, and then in a bracket 1 plus the natural log of t plus 1. And we can now divide both sides by 1 plus the natural log of t plus 1. So I've got 26 minus, and then in brackets 1 plus the natural log of t plus 1. And on the bottom we have 1 plus the natural log of t plus 1. And from this we can conclude that t equals 26 over 1 plus the natural log of t plus 1 minus 1, because minus and then in brackets 1 plus the natural log of t plus 1 over 1 plus the natural log of t plus 1 is just minus 1. And that's exactly what we wanted to show. Now for part C, we've got this iterative formula, tn plus 1 equals 26 over 1 plus the natural log of tn plus 1 minus 1. We are given that t1 is equal to 7, and with this we have to find the value of t3 to 3 decimal places, and then find by repeated iteration the time taken for the car to reach maximum speed. Well, we have our iterative formula and we have t1 equaling 7. To find out what t2 is, that's equal to 26 over 1 plus the natural log of t1 plus 1 minus 1. So we have 26 over 1 plus the natural log of 7 plus 1 minus 1. Now on our calculator, if I type in 7, this is currently stored into the answer function. And then if I type in 26 over 1 plus the natural log of answer plus 1 minus 1, our calculator now stores in the answer function t2, which is 7.443. That's given to 3 decimal places. And then to find out what t3 is, Same idea, we have 26 over 1 plus the natural log of t2 plus 1 minus 1. So we have 26 over 1 plus the natural log of the 7.4 etc. plus 1 minus 1. And if we work out what this is, we get 7.298 given to 3 decimal places. And now to find out what the value of t is, if we continue the process by continuously pressing equals until the digits no longer change, we have t equals 7.333 given to 3 decimal places. Question number 9. Figure 3 shows a sketch of a parallelogram PQRS. We're given that PQ is 2i plus 3j minus 4k. Now let's just add this onto the diagram. We have PQ equaling 2i plus 3j minus 4k. And then we've got QR, which is 5i minus 2k. So let's add this to the diagram. We have QR equaling 5i minus 2k. Now what we need to do for part A is show that parallelogram PQRS is a rhombus. Now before we do anything else, it's worth us finding out what the magnitude of PQ and QR is. Now before we do any of that, we know that opposite sides of a parallelogram are equal, so we have SR equaling PQ, which is 2i plus 3j minus 4k, and PS equaling QR, which is 5 minus 2k. So let's find the magnitude of PQ, which is equal to the magnitude of SR. So we have the magnitude of PQ equaling the magnitude of SR which is equal to, well, we have 2 squared plus 3 squared plus minus 4 squared, then square rooted, and it turns out here we have the square root of 29, and similarly the magnitude of QR, that's equal to the magnitude of PS, which is equal to 5 squared plus 0 squared plus minus 2 squared, then square rooted, and this is also equal to the square root of 29. And so what we can see then for our parallelogram, each of the sides has length root 29. So because each side has a length of root 29, we can conclude PQRS is a rhombus. Now for part B, we have to find the exact area of the rhombus PQRS. Now if we connect the opposite corners to form these diagonals, we can find out what PR is and what QS is as vectors. PR, that's equal to PQ plus QR, so I'm going P to Q and then Q to R, so I have 2i plus 3j minus 4k added to 5i minus 2k, and it turns out we get 7i plus 3j minus 6k. And then if we were to find the magnitude of this, the magnitude of PR, that's 7 squared plus 3 squared plus minus 6 all squared, square rooted, which is the square root of 94. And QS, well I can go Q to P and then P to S. So QS is equal to minus 2i minus 3j plus 4k, the negative of PQ, plus 5i minus 2k. And it turns out we get 3i minus 3j plus 2k. And if we find out the magnitude of QS, we've got 3 squared plus minus 3 squared plus 2 squared, which is root 22. And at this point, if we create a diagram, we can show those lengths. We've got PR being root 94 and QS being root 22. Now, what we have are 4 congruent triangles. Let's just draw those out. So we've got one of these triangles. Now, this would have a height of half the root 94, so here we have 1/2 times the square root of 94, and here we have the base of 1/2 times the square root of 22. And so the area of one of those triangles will be given by 1/2 multiplied by the 1/2 times the square root of 94 multiplied by the base 1/2 times the square root of 22. But then for the entire rhombus, we've got 4 lots of this, and therefore the area of PQRS, that's equal to, well, I've got 4 times by 1/8, which is 1/2, and then I've got the 22 times the 94 all square rooted, so that's 2 times the square root of 517, and if I times that by 4/8, it turns out that the area then is equal to 517 square rooted. Question number 10. A scientist is studying the number of bees and the number of wasps on an island. The number of bees, measured in thousands, NB, is modelled by the equation NB equals 45 plus 220 e to the 0.05 t, where t is the number of years from the start of the study. According to the model, we have to find the number of bees at the start of the study. So for part A, we've got NB, which is equal to 45 plus 220 e to the 0.05 t. And when t equals 0, NB, that's equal to 45 plus 220 e to the power of 0. And if we work out what this is, we get 265. And so the number of bees is 265,000. Next, we have to show that exactly 10 years after the start of the study, the number of bees was increasing at a rate of approximately 18,000 per year. Well, we know what n is, and because we are considering the rate, we need to find out what dn over dt is. And if I work out what this is, differentiating 45 we get 0, and differentiating to 20e e to the 0.05t, that means we end up with 11e to the 0.05 t. And when t is equal to 10, dnb over dt, that's equal to 11e to the power of 0.05 times 10. And if we work out what this is, we have 11e to the 0.5, which is a value of around 18. And so we can see it's increasing at a rate of approximately 18,000 bees per year. Now, the number of wasps measured in thousands, NW, is modelled by the equation NW equals 10 plus 800 e to the negative 0.05 t, where t is the number of years from the start of the study. When t equals t, according to the models, there are an equal number of bees and wasps. We have to find the value of t to 2 decimal places. Well, what we have to do is set NB equal to NW when t equals t. So, for part C, when t equals t, NB is equal to NW. And using this, we have NB, which is 45 plus 220 e to the 0.05 t. This is equal to NW, which is 10 plus 800 e to the negative 0.05 t. And so we need to solve for t. If we simplify by subtracting 10 from both sides, that means we will be left with 35 plus 220 e to the 0.05 t, and that's equal to 800 e to the negative 0.05 t. And if we multiply through by e to the 0.05 t, then we have 35 e to the 0.05 t. Perhaps if we put this in a bracket, and then we have 220, and we have e to the 0.05 t squared, and that's equal to, well, I've got 800 e to the negative 0.05 t multiplied by e to the 0.05 t, so that's just going to equal 800 times 1, which is 800. And if we take everything over to one side and simplify by dividing through by 5, so if I divide through by 5 as well, that means we have 44 multiplied by e to the 0.05 t squared plus 7 e to the 0.05 t minus 160. So I'm taking the 800 to the left hand side and dividing by 5. This is all equal to 0. Now let's use our calculator to help us find the values of e to the 0.05 t. We can use the equation function solver. We have 44, 7 and minus 160. So it turns out e to the 0.05 t is equal to 1.8, etc. Let's store this into A. And the next value, well, I get a negative number, and I know then that e to the 0.05 t cannot equal negative 1.9, etc. And so we have, by taking logarithms, 0.05 t equaling the natural log of 1.8, etc. And so t would equal the natural log of A over 0.05, which is 12.08 given to 2 decimal places. Question number 11. Figure 4 shows a sketch of part of the curve C1 with equation y equals 2x cubed plus 10 where x is greater than 0, and part of the curve C2 with equation y equals 42x minus 15x squared minus 7 where x is greater than 0. And for part A we have to verify that the curve intersects at x equals 1/2. So x equals 1/2, that would be the solution we want to find over here. We have x equals 1/2, and we need to verify that C1 and C2 intersect when x equals 1/2. Now, the way we can do this is to substitute x equals 1/2 into both C1 and C2. So, for part A, if I consider the curve C1, I know that y equals 2x cubed plus 10, and with x equaling 1/2, we have y equals 2 times by 1/2 cubed plus 10. And if I work out what this is, it turns out we get 41/4. And if I consider the curve C2, which I know is y equals 42x minus 15x squared minus 7, then when x is equal to 1/2, y equals 42 times by 1/2 minus 15 times by 1/2 squared minus 7. And it turns out here we get 41/4. And because C1 and C2 intersect at the point 1/2 41/4, we can conclude they intersect at x equals 1/2. Now the curves intersect again at the point P, and using algebra and showing all stages of working, we have to find the exact coordinates of P. So if I go back to my diagram, they would intersect again over here at some point xp, and we need to find out what xp is. And to do that, we can set curve C1 equal to C2. So if I set curve C1 equal to curve C2, we've got 2x cubed plus 10 equals 42x minus 15x squared minus 7. And if I take everything over to one side, that means we have 2x cubed plus 15x squared minus 42x plus 17 equals 0. And I know that x equals 1/2 is the solution to this equation. Now what we'll do now is we will let f of x equal this over here, the 2x cubed plus 15x squared minus 42x plus 17. Now we know x equals 1/2 is a solution to f of x equals 0, and that would imply that 2x minus 1 is a factor of f of x. Now if that's the case, what we can say then is 2x minus 1 times by some quadratic ax squared plus bx plus c. That will be equivalent to my cubic 2x cubed plus 15x squared minus 42x plus 17. And to find out the values of a, b and c, we can compare coefficients. So if I take a look at the x cubed terms, then what we have is the 2x being multiplied by the ax squared, giving us the 2x cubed. So I have 2a equals 2, a equals 1. Now if I take a look at the x squared terms, then what multiplies to give me an x squared? Well, I've got the minus 1 times ax squared, and I've also got the 2x times by the bx, and that will equal the 15x squared. So in terms of the coefficients, I've got 2b minus a equals 15. A is equal to 1. So I've got 2b minus 1 equals 15. 2b is equal to 16. B is equal to 8. And if we take a look at the numbers, then on the left we have the minus 1 times by the c, and that gives the 17. So we have minus c equals 17. C is equal to minus 17. And now that we know what A, B and C are, we can then conclude that f of x is equal to 2x minus 1 times 1x squared plus 8x minus 17. And what we are doing is solving the equation f of x equals 0. And if I solve the equation f of x equals 0, we've got 2x minus 1 times x squared plus 8x minus 17 equals 0. From this we have a solution of x equals 1/2. And if I solve the equation here on my calculator, I get x equals minus 4 plus minus the square root of 33. And as x must be greater than 0, that means the only solution, xp, is equal to minus 4 plus root 33. So I've got xp equaling minus 4 plus root 33. Question number 12. We have to show that the integral of x cubed times the natural log of x with respect to x between 1 and e squared is a e to the 8 plus b, where a and b are rational constants to be found. Now here we have the product of two functions and we are integrating. And so we would have to use integration by parts. U is equal to the natural log of x. U dash is 1 over x. V dash, that's equal to x cubed, and v is equal to 1/4 x to the 4. And so what we need to do now is integrate. So if we were to integrate between 1 and e squared, x cubed times the natural log of x with respect to x, we have v times by u, so that is 1/4 x to the 4 times the natural log of x, and we need to evaluate this between 1 and e squared, and then we subtract the integral of from 1 to e squared. V, which is 1/4 x to the 4, times by 1 over x dx. And so if we simplify this even further, we have 1/4 x to the 4 times the natural log of x evaluated between 1 and e squared, subtract the integral of, well here I have 1/4 x cubed dx. And if we work out what this result is equal to, then integrating 1 over 4 x cubed, we end up with 1 over 16 x to the 4. And we are evaluating this between 1 and e squared. So we have to evaluate 1/4 x to the 4 times the natural log of x, subtract 1 over 16 x to the 4. And we are evaluating this between 1 and e squared. So for our upper limit, we have 1 over 4 times by e squared to the 4 times the natural log of e squared, subtract 1 over 16 times e squared to the 4. And then for the lower limit, I substitute in 1 for x. So I have 1/4 times 1 to the 4 times the natural log of 1, subtract 1 over 16, 1 to the 4. And so if we simplify this even further, here I've got 1/4 times by e to the power of 8. Now here, the natural log of e squared, that's the same as 2 times the natural log of e. And then I subtract from this 1 over 16 e to the 8. And then we've got the natural log of 1, which is equal to 0, so this term disappears. And then we've got the minus and the minus, which is plus. And then I've got 1 over 16 times by 1 to the 4, which is just 1 over 16. So I've got 1/2, because natural log of e is 1, so I've got 2 times 1 times 1/4, which is 1/2. Then I've got e to the 8, subtract 1/16 e to the 8, plus 1 over 16. And so we end up with 17 over 16 e to the 8 plus 1/16. In which case we can conclude the constant a is 7 over 16, the constant b is 1 over 16. Question number 13 for the first part. In an arithmetic series, the first term is a and the common difference is d. And what we have to do is show that Sn equals n over 2 times 2a plus n minus 1 times d. So first of all, we know that the nth term of a linear sequence, un, that's equal to a plus n minus 1 times d. And so if we were to find the sum, Sn, well, we have to add together the first term, the second term, the third term, all the way up to the nth term. So when n is equal to 1, we have a plus 1 minus 1 times d, which is a. Then when n equals 2, we have a plus 2 minus 1 times d, which is a plus d. Then, when n equals 3, we have a plus 3 minus 1 times d, which is a plus 2d. And we could add other terms as well. But then the n minus 1th term, that's when n is equal to n minus 1. We would have a plus n minus 1 minus another 1 times d. That's the same as a plus n minus 2 times d. And then we finish at n. The nth term is a plus n minus 1 times d. Now let's call this equation 1. And what we will do is we will rewrite equation 1 but in reverse order. And so Sn equals a plus n minus 1 times d, and then we have a plus n minus 2 times d, and then we've got the terms in between, and then for the final couple of terms we have a plus 2d added to a plus d being added to a. Let's call this equation 2. So now what we can do is add together equation 1 and equation 2. And if I do that, we have 2Sn, Sn plus Sn, that's 2Sn. Well, we have a plus n minus 1 times d, that's 2a plus n minus 1 times d. And then we would have a plus d plus a plus n minus 2 times d. And that gives 2a plus n minus 1 times d. And then we could continue with the terms in between. But then what we'll add on finally is a plus n minus 1 times d with a, which is 2a plus n minus 1 d. And do you notice that 2a plus n minus 1 times d occurs n times? And so 2Sn is therefore equal to n multiplied by 2a plus n minus 1 times d. And if I divide through by 2, Sn is equal to n over 2 times 2a plus n minus 1 d. Next, James saves money over a number of weeks to buy a printer that costs £64. He saves £10 in week 1, £9.20 in week 2, £8.40 in week 3 and so on, so that the weekly amounts he saves from an arithmetic sequence. Given that James takes n weeks to save exactly £64, for part A we have to show that n squared minus 26n plus 160 equals 0. Well, if in week 1 he saves £10, that would imply that our first term A is equal to 10. And the difference between how much he saves each week, well, I've got £10, then £9.20, then £8.40. And do you notice we're taking away 80p each time? And so the common difference then, that would be minus 0.80. And so therefore, if we also know that in total it takes him n weeks to save £64, so that means Sn is 64. And using all this information then, if I substitute into my Sn formula, that means we have n over 2 being multiplied by 2 times by 10 plus n minus 1 multiplied by minus 0.8. So here we have minus 0.80 times n minus 1. and this is equal to 64. So now let's multiply through by 2. If I multiply through by 2 and then simplify as much as I can inside the bracket, we have 2 times by 10, which is 20, and then I subtract 0.8 n, and then I add on 0.8, and this is equal to twice 64, which is 128. And so we have n being multiplied by 20.8 minus 0.8n, that's equal to 128. And if I multiply the n into the bracket, we would have 20.8n minus 0.8n squared, and that's equal to 128. So we have minus 0.8n squared plus 20.8n minus 128 equals 0. And if I divide both sides by minus 0.8, then we would have n squared minus 26n plus 160 equals 0. And that's what we wanted to show. And now for part B, we have to solve the equation n squared minus 26n plus 160 equals 0. Well, we can factorize as n minus 16 multiplied by n minus 10, that's equal to 0, which means n is either equal to 10 or 16, so either takes 10 weeks or 16 weeks. But if we go back to the question and take a look at what we have to do for part C, we have to state the number of weeks James takes to save enough money to buy the printer, giving a brief reason for your answer. Well, if I take a look at n equaling 16, use 16, that will equal 10 plus 16 minus 1 times minus 0.8. And if I work out what this is, I get negative 2. So we have a negative amount. And so that means n is equal to 10 only, which means for us it would take 10 weeks. Question number 14. For part A, given that 2 times the sine of x minus 60 equals the cosine of x minus 30, we have to show that tan x equals 3 root 3. So, for part A, we've got 2 times by the sine of x minus 60 equals the cosine of x minus 30. And if we take a look at the trigonometric identities, we can use the identity for sine and cosine to help simplify this result. And so we have 2 multiplied by, using the addition formula, sine x times by cos 60 subtract 2 times by cos x times by sine 60. And that's what we have on the left hand side. And on the right hand side, using the addition formula, we've got cos x times by cos 30 plus sin x times by sine 30. And so if we tidy all of this up, well, I've got 2 times by the sine of 60, which is root 3. So I've got, well, rather I've got 2 times by the cosine of 60, which is 1. So I've got 1 times by sine x, and then I've got minus 2 times by sine 60, which is minus root 3. And then I've got cos x, and then I've got cos x times by cos 30. Well, cos 30, that's root 3 over 2. So I've got root 3 over 2 multiplied by cos x, and then I've got sine x times by sine 30. Well, sine 30 is a half, so I add on 1/2 times by sine x. And if I take everything over to one side involving a sine x and everything that involves a cos x to the other side, I have sine x subtract a half sine x, so that will be 1/2 sine x, and then I've got root 3 over 2 cos x plus root 3 cos x, so that is the same as 3 root 3 over 2 cos x. And if I multiply through by 2, that means sine x equals 3 root 3 cos x. And if I divide through by cos x, that means sine x over cos x equals 3 root 3, in which case we can conclude, because sine x over cos x is tan x, we can conclude tan x is equal to 3 root 3. For part B, hence or otherwise solve for theta being in between 0 and 180 degrees, 2 sine 2 theta equals cos 2 theta plus 30 degrees, giving you answers to 1 decimal place. Well, for part B, we are solving the equation 2 sine of 2 theta equals cos of 2 theta plus 30. And I am solving this in between 0 and 180. Now, does what we have look similar to what we have over here? Well, so far it doesn't. Let's just write down the equation from part A. From part A, we've got 2 sine of x minus 60 equaling cos of x minus 30, which implies that tan x is equal to 3 root 3. Now, so far these look similar in the sense on the left hand side we've got a sine of something, and on the right hand side we've got a cos of something. Now, for these to be similar, what we can see then, by inspection, x here would equal 2 theta plus 60. And if you think about why that's the case, if we rewrite this equation, we would have 2 sine of 2 theta plus 60 minus 60 equaling cos of 2 theta plus 60 minus 30, which is the same as 2 sine of 2 theta equaling cos of 2 theta plus 30. And that's a reason why x would equal 2 theta plus 60, is because we'd get back to the equation we want to solve. And so if x equals 2 theta plus 60, that would mean we have the tangent of 2 theta plus 60 degrees equaling 3 root 3. And now our original domain had a theta. Here we've got a 2 theta plus 60. So if we change the domain, 0 plus 60 is 60. And then we've got 2 theta plus 60. And then 180 times 2 plus 60, that's 420. So we have 2 theta plus 60 equals, well here I've got the inverse tangent of 3 root 3, which is 79.10, etc. So let's store this into A. And then to find my next value, I need to add on 180, leaving me with 259.10, etc. And if I store this into B, well, if I add on 180 again, I get something bigger than my interval of 60 to 420. So I'm solving for theta. 2 theta plus 60 equals 79.10, etc. degrees and 259.10 degrees. And so if we solve for theta to 1 decimal place, well, what we'll do is we'll take our values. The first one was A, and then I subtract 60 and then divide by 2. So it turns out to 1 decimal place I get 9.6. And for the next one, we would have the 259.10, etc. subtract 60 over 2, which is 99.6. So our solutions here are given to 1 decimal place. Question number 15. A company makes toys for children. Figure 5 shows the design for a solid toy that looks like a piece of cheese. The toy is modelled so that the face ABC is a sector of a circle with radius r and centre A. The angle BAC is 0.8 radians. The faces ABC and DEF are congruent. The edges AD, CF and BE are perpendicular to the faces ABC and DEF. The edges AD, CF and BE have length h. We're given that the volume of the toy is 240 centimeters cubed. And for part A, we have to show that the surface area of the toy, s centimeters squared, is given by s equals 0.8 r squared plus 1680 over r, making a method clear. Well, how would I find the volume? For part A, for me to find the volume, well, I have 1/2 r squared times by 0.8. This is the area of the sector. And then I times this by h, which is the height. And I know that this will equal 240. So I've got 0.4 r squared h equals 240. H is equal to 240 over 0.4 r squared, from which we can conclude h is equal to 600 over r squared. Now the reason I want to find out what h is, for my surface area I don't have anything involving h's, so I eventually will need to eliminate the h. Now if I was to find an expression for the surface area, I've got the face on the top and on the bottom. So I have 2 because of the top and bottom times 1/2 times r squared times 0.8. So that's the face on the top and bottom. And then if I go back, I've got the side over here and I've also got the side over here. So I've got twice r times by h because it's a rectangle. I've got h times by r. And then I've got this face at the front. Well, the curved bit over here, that's the arc length. That's 0.8 r. But then I need to times this by the height over here of h. So let's tidy this up. I have s equals 0.8 r squared plus 2 rh plus 0.8 rh, and simplifying this even further, we can see then s equals 0.8 r squared plus 2.8 rh. Now if I call this equation 1 and this equation 2, I can substitute in 1 into 2. So I have s equals 0.8 r squared plus 2.8 r multiplied by h, which is 600 over r squared. And what we can conclude from this then is r equals 0.8 r squared plus 1680 over r. And that's exactly what I wanted to show. Then for the next part, using algebraic differentiation, we have to find the value of r for which s has a stationary point. Well, what we need to do for part B is first of all differentiate. And if I differentiate ds over dr, well, here differentiating 0.8 r squared, I end up with 1.6 r, and differentiating 1680 over r, I end up with minus 1680 over r squared. And because we are considering the value of r for which we have a stationary point, that means I have to set equal to 0 ds over dr. And if I do that, I've got 1.6r minus 1680 over r squared equals 0. So r cubed, that's equal to 1680 over 1.6. R cubed is equal to 1050. R is equal to the cube root of 1050. And if we work this out, the value of r for which we have a stationary point, we have the cube root of 1050 which is 10.2 centimeters given to three significant figures. Now let's store this into A just in case we need it later on. And then for part C, prove by further differentiation that this value of R gives the minimum surface area of the toy. Well, for the next part, what I have to do is differentiate again. So I need to differentiate again ds over dr. So if I differentiate ds over dr, the second derivative, d squared s over dr squared, that would equal 1.6 plus 3,360 over r cubed. And with r equaling 10.16, etc., we have d squared s over dr squared, which is 1.6 plus 3360 over 10.16, etc. cubed. So if I work this out, I've got 1.6 plus 3360 over that cubed, which is 4.8. Now, because this value here is certainly greater than 0, the stationary point is therefore a minimum. So the r equals 10.16, etc. centimeters gives a minimum surface area. Question number 16. Figure 6 shows a sketch of the curve C with parametric equations x equals 8 sine squared t, y equals 2 sine 2t plus 3t, where t is in between 0 and pi over 2. The region R, shown shaded in figure 6, is bounded by C, the x-axis, and the line with the equation x equals 4, and we have to show that the area of R is given by the integral from 0 to A of 8 minus 8 cos 4t plus 48 sine squared t cos t dt, where A is a constant to be found. Now, to find the area under a parametrically defined curve, well, usually when we integrate between x equals p and x equals q, say, of y with respect to x, that would tell us the area. But then the problem is x and y are in terms of t. So the way we can adapt this integral is to expand the dx. And if we do that, we would be integrating y times dx over dt with respect to t. It's as though the dt's cancel, and you'd find that our limits this time are in terms of t. Now, we need to work out what dx over dt is, and we also need to work out our limits. Well, we know what x is. X is given by 8 sine squared t. And so I will rewrite this as 8 times by sine t squared. And so differentiating to find out what dx over dt is, 2 times 8 is 16, multiplied by sine t, and then differentiating the sine, we get cos t. So we have 16 sine t times cos t as dx over dt. Now, we've got one limit, x equals 0, and another limit, x equals 4. So, when x is equal to 0, I've got 8 sine squared t equals 0. sine squared t is 0, sine t is 0, which means t is equal to 0. We also have our upper limit x equals 4. So when x equals 4, we have 8 sine squared t equals 4. Sine squared t equals 1/2. Sine t equals 1/√2. T equals pi/4. So now we can integrate. So the area of R, that's equal to the integral from x equals 0 to x equals 4 of y dx. And we've already found our limits in terms of t. We are integrating from 0 to pi/4. And then we have y, which is 2 sine 2t plus 3 sine t times dx/dt, which is 16 sine t cos t, and then we are integrating with respect to t. So now we need to tidy all of this up. Now the way I will tidy this up is to expand the brackets. So I'm still integrating between 0 and pi/4. 2 sine t times by 16 sine t cos t, well, that is 32 sine 2t times by sine t times by cos t, and then I've got 3 sine t times by 16 sine t cos t, that's 48 sine squared t cos t. dt. And now we can simplify this even further using the double angle formula. The 32 sine 2t sine t cos t I can rewrite as 16 sine 2t multiplied by 2 sine t cos t, because the 2 times the 16 gives the 32, and the rest of the integral remains the same. We add on 48 sine squared t cos t dt. And continuing to simplify, I've got the integral from 0 to pi/4, and then I've got 16 sine 2t multiplied by, here 2 sine t cos t, that's the same as sine 2t, and then I add on 48 sine squared t cos t, and then I'm integrating all of this with respect to t. So I'm integrating between 0 and pi/4. Here I've got 16 sine squared 2t, because I've got sine 2t times by another sine 2t, and then I've got the 48 sine squared t cos t dt. And what we can do is, if we go back to what we want to show, here the 48 sine squared t cos t still exists, but here I've got 8 minus 8 cos 4t. And what we have to do over here then is use the identity for cos 2a. So I can rewrite the 16 sine squared 2t as 16 over 2 multiplied by 1 minus cos 4t. So 1 minus cos 4t divided by 2 is the same as sine squared 2t. And then I'm adding on this bit over here. And 16 over 2 is 8. So I've got the integral from 0 to pi over 4 of 8 minus 8 cos 4t plus 48 sine squared t cos t dt. And if I make a quick note, the value of a is pi over 4. Now, we have to use algebraic integration to find the exact area of R. So, if I move this to the side, over here for now. Continuing on for part B. For me to integrate this, well, I'm going to rewrite the 48 sine squared t cos t. And I'm going to rewrite it as follows. I'm going to rewrite it as 48 times by sine t squared times by cos t dt. And the reason I'm going to rewrite this is because when I integrate, it becomes much easier to use the reverse chain rule in this case, because the derivative of the bracket, the derivative of sine t is outside the bracket. The derivative of sine t is cos t. So, if we work this out, integrating 8 with respect to t, we end up with 8t, and integrating minus 2 cos 4t, end up with minus 2 sine 4t, and then integrating 48 sine squared t cos t, well, if I add 1 to the power and then divide by the new power, then what happens is the cos t's cancel out, well, I need to add 1 to the power, divide by the new power, and then divide by the differential of the bracket rather, which is cos t. And so if we continue to simplify this, we have 8t minus 2 sine 4t plus 16 sine cubed t, and I'm going to evaluate this between 0 and pi over 4. So, if I substitute in for my upper limit, then I have 8 multiplied by pi over 4. Then I subtract 2 times by 4 times by pi over 4 plus 16 sine cubed of pi over 4 and then for my lower limit I've got 8 times by 0 minus 2 sine of 4 times by 0 plus 16 sine cubed of 0, and this is what I need to work out. Well, the bracket, the second bracket would simplify to 0, and so I have 8 times by pi over 4, which is 2 pi, and then here I've got minus, well, let's just change to radians. I've got minus 2 times by the sine of pi, which is 0, and then I've got the sine of pi over 4, and then this is cubed, so I have 16 times by 1 over 2 times by root 2 cubed so I've got 2 pi plus 16 times by 1/8 times by root 2 cubed, so I've got 2 pi plus, well here I've got 16 divided by 8, which is 4, rather 16 divided by 8, which is 2, and then I've got root 2 cubed, which is 2 root 2, so the area is equal to 2 pi plus 4 root 2 units squared. This is my final answer, and this is what the area of R is equal to.